this video, I'm going to show you on Form 4, Chapter 2 for Physics. Form 4, Chapter 2, we have force and motion. So the first part of it, there are actually a few parts in Chapter 2. And Chapter 2 in Form 4 comprises about 30% of the average of the overall paper. So if you are doing very well in Form 4, Chapter 2, you will be able to pass physics, okay? Because but if you didn't do well, in this chapter, then you have a very, very hard time, going through it. So, lucky or not, you need to excel in this chapter. So, what you will learn, force is actually more mass time acceleration, but we'll get to that later. So, how about motion? In motion, there are two. One is linear motion, meaning an object move in a straight line. Okay. Well, move from one point to another. Okay, that's a linear, the straight line. And another types of motion we call non-linear. When it's non-linear, which means when the object is traveling, yes, in a circular motion, goes around over the same center, maybe at the center. Yeah. So in physics Form 4, you will learn linear motion. Non-linear, you doesn't really need to learn it, but I will try to use it as, for example, how to differentiate between distance with displacement. Now, so first part of it, as what you have seen from my blog, I'll arrange it according to kinematic dynamics. So the first part will be kinematics. So kinematics, what do you learn? Kinematics is all about motion. Okay, it's a study of motion. Okay, it's a study of motion. What is so great about the motion, you ask? So what motion? An object move initially very slow, and then towards the end of the journey, move very fast. So from slow to fast, then what happened? It says is, then they name it as acceleration. The object accelerate. Okay. Likewise, if the object move very fast initially, and then later slow down itself, caused by friction maybe, then that object was said to be being decelerated. So this is what you will learn in kinematics, study of motion. Without considering the force, without knowing the force. Okay, without knowing the force, what's for on it. So what you will learn here is to study of it. How do you learn it? They will normally ask you to calculate what's the speed, what's the distance, what is the acceleration, and how long does it take for an object to travel from one place to another. Okay, so the next part will be called dynamics. So dynamics we will study is a study of motion. Okay, study of motion of an object, and motion of object and the force act on it. Okay, the force act on it. Okay, so that's the difference. Okay, so for kinematic it's all about motion. For dynamic is motion and the force act on the object. Okay, I'll start with kinematics. As for in kinematics, okay, there are a few terms you need to know, and you need to be able to identify them. How do they differ from one to another? First one, simplest one, is called distance. You have to know what is distance. Distance is a total length. Okay, a total length travel. Okay, it's a total length. Length, measured in meter or kilometer, depends on one object. If it is a car, then maybe traveling kilometer. If walking distance, then maybe it's a few meter. Okay. Then what else need to know? Total length of a path travel. Okay. Total length without taking the total length, without knowing the distance, without knowing the direction, without taking the direction, because taking direction. Okay. So distance is actually what I have learned in a previous video, from a previous video, is actually a scalar quantity. Okay. Okay, it's a scalar quantity, normally measured in meter. Likewise, distance, likewise displacement. Okay, you need to be very careful about this word, and you need to know what's their difference. Okay, displacement is actually the distance travel. It's a distance travel in a specific direction. Okay, in a specific direction. Okay, and displacement is a vector quantity. So it has magnitude and direction. So let me give an example. How do you differentiate? A very clear path would be by looking at the map. Okay, if you were to have a map, okay, you want to travel from, there are in your GPS coordinate, maybe you are here and you intend to travel from this building to this building, here to here. Okay, so there are a few things in the map. Okay, from a map, maybe here is your north. Yeah, this is what you will normally see. Okay, so which one is distance, which one belongs to displacement? Okay, now displacement, let's start with displacement, is distance travel at specific direction. So meaning if you were to travel, really travel, so what you do, you will travel from here, you start from here, right? You go up and then to the right, then you reach your destination. So this one here is called displacement. So displacement, because initially you need to travel north by this amount of distance and then travel east for this amount of distance, then you will reach your destination. So that's displacement. Likewise, for the event, for the event of distance, how about distance? Is a scalar, total length without taking direction, total length. So here, total length from here to here. What's the distance from here to here? So that's the distance. This is called the distance without knowing the direction, just the rough distance. It's not the distance that you really actually travel, because there are some obstacles. You don't have road around it, so you need to go north and go east. So that's the displacement, north and east. This amount of distance, this amount of displacement. Okay, so this is how you normally differentiate them. I hope you were able to know it, because it's very hard without knowing it. Distance is just 2 points. Measure the 2 points without knowing what are the obstacles in the land. Okay, right? So that's the distance, the concept of distance. All right. Okay. Next, we'll talk about length. Next, we'll talk about how fast. Okay, because we'll study about motion. So next, we're going to study how fast. How fast an object moves. Okay, how fast. The first part is the previous page. We learn about distance, one point to another, or displacement, where to where. Okay, then next we will study how fast from here to here. How long does it take? Okay, regardless of whether it's traffic jam or not. Alright. Okay, that's a joke. Alright. So how fast? There are also two. First one, how fast? What's the speed? Speed, by definition, how to define it? Speed is rate of change. Rate of change. Rate of change in distance. Rate of change in distance. So meaning distance, just 2 points. Okay. So therefore, it's a scalar quantity. You need to be very clear about this. Scalar quantity. So the equation speed is u, maybe dimension, is therefore rate of change something over time, quantity. Okay? Then here would be distance. This quantity, therefore the unit would be meter per second for speed. Okay? Right? So u, small u. Second one, you have speed. Next thing, you have velocity. C-I-T-Y, velocity. Velocity, they have the same equation. It's a rate of change. How fast, right? How fast? Rate of change in displacement. Okay, displacement. Therefore, it will be a vector quantity. Let me give you an example or give you a sense of what does it mean by how fast. Now, speed or either speed or velocity is not limited to only car, or motion is not only limited to vehicles. Yeah, concept of speed, how fast thing grows. Say for example, the stalactite or stalagmite. Yeah, the growth rate or the speed would be how many micron per century, maybe how many micron per decade. So that is also some way to represent speed. But instead of meter, it is in micrometer, because you don't expect stalactite, grow a few meter in a second. Then that's very scary. The same is true in biology. Yeah, the growth rate for an embryo. Okay, the cell divides. Maybe how fast did they divide? 2 cells in every microsecond. Right. So there is not so speed and how fast. The concept of how fast is not limited in physics. It is limited across the science stream. The science field. You have chemistry, or you have biology. You have chemistry, rate of reaction. How many precipitation forms over time. How many grams form per time. So the concept of speed, is not only in physics. That's why it's important to take physics. You're able to relate them across the subject. Okay, let me come back to here. Vector quantities for velocity, they have the same unit, just that now you have small v. Is also something over the time quantity, dimension of time, but here is displacement. Okay, so meaning you need to report your answer to be in how fast in which direction. Okay, unit also meter in second, and also you need to know whether it's north or south. Okay, also direction, due east, due west, to the left, to the right. For example, you give a sense of direction. Okay, then you have how fast. Then later you will be is it always fast, or initially fast, later slow down? Okay, fast or slow? Okay, maybe now I will read fast or slow. Okay, whether it's fast to slow or slow to fast, we define it as a common term as acceleration. Okay, maybe we'll use another color to help you out better visualize this concept. Acceleration. Okay, acceleration is the velocity of object changes with time. Okay, is a rate of change. Rate of change in velocity or speed. We will start with speed. Okay, how fast an object change? How fast will the object accelerate? It depends on how fast it changes speed over time. Okay, so the equation, now you have a first equation. We say A acceleration is actually the final velocity minus initial velocity over the time difference between them. Okay, minus u over t. Now you here, then you say you were confused. Why is it v and u comes together? Isn't it that v is the velocity, u is a speed? Now, depending on how you want to look into it, okay, for acceleration, those symbol is not limited, yeah, to only speed and velocity. And acceleration, v, u, sometimes you will use it. If you want to doesn't want to confuse yourself, yeah, with the v and u, then maybe I would change it to maybe final minus initial is always the case. Then I would say the u, since I say it's a speed, if I define it velocity, then I will use u. Final, capital, small f, and initial, I, subscript I, over the time changes, time of change, maybe a triangle, change of time, okay? I think I'll write it better this way, so that acceleration will be, since I'm using speed, then I will use u, final velocity, subtract initial velocity over the changes of time between them. Okay, I'll talk about what does it mean by that. Okay, but for now, you just make do with the equation. So, if you subtract two numbers, yeah, initial, finally, at the final acceleration is say very fast. Yeah, let's say 50 meter per second, but initially it's only 5. Okay, meter per second. Then the time for it to increase from 5 to 50 is 6 seconds. So therefore, you subtract them and divide by the time. Okay. So so for this case, if my final velocity is greater than initial velocity, what do you get? Fast, slow. I will define this. You get a positive number. Therefore, you will be saying this object is accelerating. Okay, because the A will be greater than 0 in this case. Likewise, if my final velocity number is smaller than initial velocity, initial very fast, the end very slow, then this object I would say is decelerating. Okay, decelerating. So you get A less than 0, less than 0. Okay, it's a matter of calculation. And even if you define, okay, since I define speed, but normally acceleration, I wouldn't say speed. Some question they will normally talk about speed. Acceleration will normally define in velocity. Because why is that? Because it is actually a vector quantity. It's vector quantity. Which direction is traveling? Decelerating at which direction? Unit, nominator is speed, so it's meter per second. So you have 2. Okay, unit. Okay, meter per second. You may go through your reference text on how do you actually measure the speed. In the lab, you have a ticker timer. By studying the ticker tape, yeah, a spin question normally 50 dots in 1 second, the frequency. So one dot to another dot is 0.02 second. So you calculate how many dots are there, and then you times them, and you get to know, okay, from one point to another point, how long does it take? Then that's the duration. Now, you need to look through your reference on ticker timer. how do you get the ticker tape, and or perhaps you get into school during the lab, you pay attention during the experiment session, and how do you actually measure the speed, and how do you measure the velocity. Okay, so in next part, I'm going to show you on the equation. Yeah, analyzing. You may pause this video, go through the ticker timer, ticker tape. How do you look at it, and then the concept will always be come back to what I have mentioned earlier. What happened when initial velocity, final velocity greater than initial velocity, then it's accelerating. So by looking at the ticker timer, ticker tape, you should be able to tell how. Yeah. For if the dot to dot, the distance between dot to dot is very close, then the sense of moving very slow. But when a dot to dot is very far apart, then it's actually very fast. Okay, if the dot to dot distance is always the same, then the speed is actually called constant velocity. Okay, so you really need to go to school. You need to attend school. You need to attend the lab session, because it's very hard to show you over here. But next, maybe I can show you on the equation. The equation for linear motion. Equation. For linear motion. Because it's also possible to have other kind of motion, projectile motion, but you didn't learn yet, yeah, over here. So let me give you some head start. So earlier, previous page, we learned acceleration is actually final minus initial. I will be using this symbol. V represents final velocity. U represents initial velocity. Okay, for the sake of acceleration, I'll be using that. Okay, even I'm not me, even at school, you will still use that. Okay, U, V. V is final, U will be initial. Okay, and for the reference purpose, or for your own understanding, we have learned earlier also, velocity is actually distance over time. Okay, or velocity is displacement over time. Yeah, but here I would use the word distance travel. Okay, if the distance towards that direction and towards that direction, so D, I will, since if you will say, oh, velocity stick to displacement, then we'll use displacement over time. Okay, displacement over time. So you'll be able to calculate the distance or displacement. So easily you just bring up the T, then you get displacement. D is what? And yeah, bring around the equation, algebra. So first thing is these two equations. Then next, what you'll learn to help you understand the equation better would be, now there are some graph actually, and it will be easier always to bring out a graph. Okay, says this is for your mental for your understanding. Okay, now for a graph of maybe velocity versus time 0, and we doesn't know if we know that, oh, when it's 0 it's already moving. Okay, linearly with time. Okay, so you'll be able to shout out the equation for this equation actually, because I'll say, oh, y-intercept is initial, I will say it's u. Okay, and for your information, the gradient, okay, the gradient here to here is actually, the gradient is actually the acceleration gradient of graph. Yeah, you look at this equation on top here. Okay, Maybe you want to say, oh, it's change of time. Okay, change of time, right? So the gradient for a graph of velocity versus time, the gradient for this graph is actually acceleration. So easily you will be able to tell this equation of this line would be v is equals to at plus u, or in some book they say v equals to u plus at. They memorize it so hard, right? Here I'm giving you an alternative not to memorize it, to understand it. A graph, and this is equation. Okay, a VOT graph, then this is equation. Right? Now, with this graph also, there are a few things we're able to, some information. Yeah. What else? Now, if you want to find out the equation easily, you get this equation, right? I will tell you. I've told you how to do it. Next thing about this equation, d distance is actually vt, right? From the concept, yeah. This concept, distance is actually the the v quantity times time quantity. Okay, this is the concept. Now, here, if you were to have a graph of vt, the same graph you're using it, if you want to find out the total displacement, okay, total displacement from t0 to maybe time t final. Okay, if you want to find out what's the total distance traveled by your object, all you need to do is you find out what is the area. Okay, you will find out the area. Area under the curve would actually be the displacement. What is this area? Okay, in order to do that, how you do? Simply by getting this trapezium. If you look carefully, it's actually a trapezium, right? Here is a trapezium. Here to here and to here is a trapezium. It's a trapezium. What's this trapezium? The area of this trapezium. If you found this area of this trapezium, then you will be able to tell what's the displacement travel. So, hard? Physics hard? No, I don't think so. There are lots of equations to memorize? No, not really. There's only one graph. If you're able to recall this graph, then you should get the equation, because v over t graph, linear graph. First of all, call out its equation. Next thing what you can do is to find out what's the area under the graph. How do you find it? So therefore, my displacement S is, in order to get a trapezium area, what we could do is 1 over 2 half times initial here is to here is obviously u. The final acceleration, our final velocity is v. So what we do is u plus v times the t final, total time travel, here to here. So you need to know how to interpret this graph. Then you get your equation. Then you say it's very hard, because you say, oh, you need to memorize it, right? Then the rest would be of substitution and replacement. So, okay, maybe sometimes it never tells you acceleration, but you need to find out what's the or final acceleration. You want to find out one thing or another. What we do? Okay, what about if I were to suggest? How about substitute v into this equation, because you doesn't know what's final acceleration or final velocity. So what you get? You get another equation. They will tell, oh, you need to memorize an equation. Actually, it's not. Yeah. If you substitute into it, you times it in, half times in t, and rearrange them. You get a new equation. It's actually called S equals to u t plus half a t squared. Okay. sound logic, right? I mean, what happened? If you times 2, make sure you times both in. You times 2, this 2, half. You need to times to u. At the same time, you need to times into v. Okay? So u, v substitute, you get 2u plus at. Then half times it in, you get ut. U and t times in ut. Then you have a t here, you times a t, you get t squared. Half is from here. Okay? So you get your second equation easily. Then what else? Yes. How about I don't want to substitute v now? I substitute what is t? Another color perhaps. Okay, this t. I doesn't know how long does it take. I have u, I have v, you have t. Rearrange it, substitute into here. You get the third equation. This is okay. Maybe I try to rewrite this. S is therefore half again u plus v. Now your t is actually v minus u over acceleration a, right? Because you need to t bring it up, yeah, to bring it down, right? So a plus b, a minus b, then you get u squared minus v squared, right? Or v squared minus u squared. Rearrange this. Okay, maybe you say I'm not good at it. Maybe can you show me once? Yeah, no problem. Then this is 1 over 2. You have v squared minus u squared. Because 1 plus a plus b, a minus b, this is a law, okay? Or a. Then you rearrange it to get one straight line, one line. I mean, there's no denominator, okay? Eliminate denominators, you bring it up, so therefore you get rearrange that. V squared is equals to u squared plus 2as, okay? So this is a matter of rearrangement, okay? You don't actually need it, it just need for you to show you how to do it. So there are actually a few equations that you should know, okay? First one here, acceleration. And then second one here, ability to look for the equation over a line v over t. Then third one would be ability to look for the area under this graph. You get displacement. Then substitute v, then you get this equation, the fourth equation. Substitute v from second equation. And then fifth equation is you substitute t with the first equation. You get the fifth equation. So there are a total of 5 equations that you should know for linear motion. Okay. Now, I doesn't need to show you how to work it out, because you may try this 5 equation. This is the method. You learn the method from here and make your own notes, and then you'll try those video. Okay. Let me know if you need any help. Yeah, you can text me or perhaps drop me a personal message. You need to try at least 8 questions, and you should have at least 2 to 3 workbook, chapter by chapter workbook. Yeah, 2 to 3 of them to try on it. Because you need to not only learn this equation, you need to learn sometimes the number is a negative number, because it's moving to the left, then it's negative. If you move to the right, then it's positive. If it were to be accelerating, then the acceleration is positive. But when it says decelerating, then decelerating, then therefore the acceleration is negative. You need to those technical things that can't be covered fully, but you need to really find out yourself. I mean, you work through the workbook or your reference textbook, reference book, in order to really excel in this part. Okay, so that's all from me. I hope my method here helps you, and I hope you press on the thumbs up button. It means you like it, and it costs you nothing actually. Yeah. So I hope you really go through those textbook. Exercise 8 to 10 questions on how to solve it. But this 5 equation, 1, 2, 3, 4, 5, it should be at your fingertip. You should be very good at it. Whenever you have questions, says you were given initial velocity, you were given acceleration, you were given time, then you will know, oh, okay, use fourth equation. Yeah, sometimes they never let you have time. They let you initial velocity, they let you acceleration, they let you know displacement. They ask you for final velocity. Yeah, final velocity. All you need to do is you insert to the final answer. It's v squared equals to u squared to s. You need to be very good at it. At least this graph would help you to understand the concept, interpretation of graph. Okay, that's all from me. Stay tuned to my next video.